Okay, so factor trees. Yeah, we're not going to do this elementary version. It's going to look a little bit different like this, so I just want to put that there for your amusement. Haha, funny one, right? Okay, let's get rid of that crap. Plus, it looked more like a mushroom cloud anyways. Anyway, okay, so factor trees. This is actually just going to help demonstrate the point I just finished making about 64, for example. Okay, in that if we reduce it down to its prime factors, okay, we can do that in a few different ways here. So watch this here. I'm going to take 64 and split this into 2 and 32. Okay, and I chose 2 because it's the smallest prime number, and that's what we want to do, get all the prime factors. And I can keep splitting it, so I can go, okay, well, 2 and 16 make 32, like that. And I can continue all the way down until I run out of numbers, run out of prime factors. And you see that I get a whole bunch of 2's that all make up 64. So I have 1, 2, 3, 4, 5, 6. So in other words, 64 is equal to 2 times 2 times 2 times 2 times 2 times 2. Okay? And we can group those in a bunch of different ways. Okay? For example, we've seen how we can group it in groups of 2. So I have 3 groups of 2 all being multiplied together. So in other words, 4 times 4 times 4. In other words, a cube root of 64 could be written as 4. Or we can group it a different way, in groups of 3, which gives us 2 cubed times 2 cubed, or in other words, 8 times 8. That's why the square root of 64 is 8. Okay? And if there's another way we could write it, maybe as a fourth root, if it was possible to divide it into 4 groups. But because there's 6 2's, I can only divide it into 2 or 3 groups. Okay? I guess we could look at also if we had just the 2's, for example. In other words, it's 2 to the power of 6. So just that's it. Okay. So anyways, factor trees kind of enable us to see how we can break those things down. Okay. So let's look at a different example. I'll show what I'm talking about here. Okay, let's take 192 for instance. If we apply that whole factor tree thing, in fact, you can do this right now as well. Write out all the prime factors of 92. Go ahead and do that now. Sorry, 192. Okay, so you see that we have 2 times 2 times 2 times 2 times 2 times 2 times 3. And I can't break that up into any number of equal groups. In other words, where if I put brackets here, okay, that leaves me with somehow I have too many over there, too many factors, and not the same factors. So I can't split this up evenly, and so therefore 192 is not a perfect square. And you know that already anyways, but you can sort of see how factor trees enable you to kind of figure that stuff out. But numbers that can be written in multiple ways, this can be a fairly easy way of figuring out how you could write them. For example, all right, so take 4096 here. If you split this into all its prime factors, well, you know what? I'll let you do that. See if you can figure all the prime factors there, and then try to write it as many different ways as you can in terms of different, multiples or sorry, powers of 2 or 3 or 4 or whatever. See what you can work out there just by using a factor tree. Okay, that was a long one. Okay, so here is a bunch of ways you could write this. You could break this up like this, as in 64 squared, or 2 to the power 6 times 2 to the power 6. Or you could do it this way and call it 16 cubed, because 2 to the power 4 is 16. Or you can do it this way as well. There's 8 to the power of 4. And lastly, but not leastly, there's 4 to the power of 6. I guess you could also say it's 2 to the power of 12, either way. So there you go. Lots of different ways that we could break that up. Factor trees help us do that. It's so exciting. I know, the best. Okay, I can't really think of anything else to show you, so we'll just kind of leave it there, and Mrs. Armitage will take over on Tuesday morning. All right, folks, talk to you soon.